there we move to questions from our lovely audience. 15 minutes, depending on the questions that will come. So kindly do not hesitate to send your questions in the comment section. After that, we will be concluding with our conclusion statements from each part, which is 5 minutes. I would beg that those of us watching, in as much as we be sending our comments, let us be very, very friendly and respectful in them, as well as the two of us here, or the two parties here, would also be very, very respectful to each other throughout this program. We move on to welcome each of us, our brother Danso Derek, and our brother
Marcus Imbro.
So, without much ado, we would give the opportunity for our brother Marcus to begin his opening statement. 25 minutes. Brother, you're welcome, and your time starts from now.
Thank you very much, Seth. Good evening, everybody joining us. Today we are asking fundamental questions about the origins of our universe. I am Marcus Imbro, and I'll be talking about the Big Bang cosmology. As we know, this question about the origins of our universe is a fundamental question that has been asked by our ancestors for a very, very long time. They will ask these questions just to probe how everything that we see around us came into existence. And it's a very important question. And I would begin my presentation by considering early cosmologies of the universe, things that our ancestors thought of and wrote about. And then we look at modern cosmology. And then how do we know that the universe began at the Big Bang? We'll be looking at that as well. I will summarize the Big Bang, and then we will look at a few misconceptions about the theory, and we will draw some conclusions and the implications of the findings. So basically, as I mentioned earlier, this is an issue of theoretical, experimental, and observational science. And that is exactly what we'll be looking at today. So we begin with the early cosmologies of the universe. In ancient times, especially Mesopotamia, we find out that people of the old times, the Sumerians, the Akkadians, the Babylonians, these people asked the same questions we are asking today. Where do we come from? Where did it all begin? And they had records, most of which are creation stories. And they viewed the world in a particular way, usually with a God beginning with creation. That is a pre-existing God beginning with creation. However, we find that these stories, these creation stories, permeated all these cultures in ancient times. So you find the Egyptians, you find the Sumerians, as I mentioned earlier, you find the Akkadians, and lots of other traditions coming up with their own creation stories. And in the early 16th and then 17th century, you find the Christian group also picking up this idea. Previously, it was taken up by the Jews, who also had to provide a creation account and was recorded in the Bible. So in the 16th and 17th century, you find an Archbishop, James Ussher, making a prediction about the origin of the universe. He predicted that the universe started 6,000 years ago. Shortly after, you find another theologian by name John Lightfoot. He also predicted quite precisely that the universe began on 23rd of October 4004 BC. That was quite a prediction, given the source material. We will move to modern cosmologies and expand our understanding on how we know that the Big Bang actually occurred. And as I mentioned, that is a matter of theoretical, experimental, and then observational science. So in modern cosmology, we find that a brilliant scientist called Albert Einstein theorized the theory of general relativity, publishing his findings in 1915, in which his equations were taken up by other scientists. to solve these equations and then find a way to resolve fundamental questions about the origins of our universe. So, in the 1920s, Vestal Slipher, who was an astronomer, finds that the universe is expanding by observing stars in galaxies far away. He saw that these stars are moving away from us. That is, the stars, the light that he was seeing was redshifted. I'll use some scientific terms, but I'll break it down so that everybody can follow the discussion. So he saw that these stars in the galaxies were moving away from Earth as points of view. And later on, Einstein's equation, which motivated this theory of the Big Bang, had to be solved by a brilliant scientist called Alexander Friedmann. He found solutions to Einstein's equation and saw that the universe can expand and the universe can also contract. And these equations we call the Friedmann equations. So basically we find that these scientists were trying to deduce from Einstein's theory and perform the maths to know the state of our universe. So after the equations, that's Friedmann's equations, other scientists took to the challenge to solve Einstein's equation. One of them was George Lemaitre, who is the father of the Big Bang, the one who proposed the Big Bang. He also found non-static solutions to Einstein's equation. Basically, he found that the universe can expand. And it led to one of the famous metrics in telling an expansion of a universe, which is the Friedmann-Lemaitre-Robertson-Walker metric. It's basically math. And that automatically leads to the expansion of our universe. So, how do we know that the universe is expanding? Another scientist called Edwin Hubble had to observe and confirm Vestal Slipher's observations. So, on Mount Wilson, there's an observatory there which Hubble took his telescope, the Hooker telescope, looked into the atmosphere, and he found that these stars in galaxies away are moving away from us. So as these stars move away from us, their light moving towards us redshifts. What that basically means is that if the light that was emitted with high energy, traveling through space-time to us, the energy reduces. And so you find it at the red part of the spectrum. We will explain these further as we go on. So after Hubble's observations that the universe is expanding, it made more sense in Einstein's theory of general relativity, because solutions from Friedmann had already proved that our universe can expand. So after that, further confirmation had to come in. So we are looking at the observations that led to the conclusions of the Big Bang. And so what Hubble basically looked at were cosmic candles. These are stars, two categories of stars: Cepheid variable stars, which are stars that shine at particular brightness and then dims, and then a type 1 supernova, that is basically a star in a system. That is a star, a white dwarf, that is, a white dwarf is basically a star that has died, that has exhausted its thermonuclear fusion, which is what gives the star the ability to counteract gravity. What that means is that as the star is there, like our sun, there is nuclear fusion at its core to produce radiation to counteract gravity. And gravity, as explained by Einstein's equation, is trying to push in the star, to collapse the star to a single point. And so when the star runs out of that fusion at its core to counteract that force that is pushing on it to collapse it, it dies and it becomes a white dwarf. So our star, which is the sun, will become a white dwarf. So he saw, by observing these stars, that we can extrapolate, taking the maths of that's the Freeman equations, and then the observations by Mr. Slipher, looking at the distances that these galaxies are from Earth, distances that were measured in light years, and the universe itself moving these galaxies away from us, meaning that they are not bound to us, they are not gravitationally bound. That's the technical word to say that they are not within our space for us to move towards them. So they are moving away. They are moving away from us. So this would be an illustration or an animation of how the universe expands, where you would see two galaxies at a point in time, and due to the expansion of the fabric of space-time, the light that is moving from one galaxy to the other red shifts. The light gets stretched. We would look at this technically when we get to look at the electromagnetic spectrum and how we can imagine the redshift of galaxies. And so, after these observations, basically telling us that the universe is expanding and that we can solve Einstein's equations, rewind the cosmic clock, and go back in time and see what actually happened, we were able to calculate the age of the universe to be 13.8 billion years. Now, that results from Hubble's equations after he observed the universe and saw that the universe is expanding. You can do this at home. If you drive and you drive, say, 100 kilometers and you moved at 10 kilometers per hour, you can know the time that you moved at that distance of 100 kilometers. You can know the time by dividing just your distance by the speed that you moved at. So here, moving 100 kilometers and then moving at a speed of 10 kilometers per hour, you know that basically you have spent about 10 hours. And so if you apply that concept, we can know the rate of expansion of the universe. And the inverse of that rate gives us an idea about the age of the universe. And these are all mathematical evidence and proofs that informed astronomers and physicists that the Big Bang actually occurred. However, that wasn't enough. There was supposed a prediction of a relic, and that is a cosmic microwave background. So if the universe began in what people misconceptualize as a hot Big Bang and came out of nowhere, there should be something indicating that it began from radiation. And our earliest evidence to tell that it actually happened as the theory propounds is the cosmic microwave background. Now you can perform an experiment of this. Those of you who had a tikopo is an old TV. It's an old TV, a rabbit ear. You can perform an experiment with this. Basically, that TV is designed, its antennas are designed to pick a portion of waves. And so, you turn on the TV, back in the old days, and then you see a static white, in our local language, we call it wansma. You see the static white display on the TV, right? If you orient your antenna in a particular way. And then you find out that 1% of that is static. No matter what you do, you will still receive that. That is away from the radio signals on Earth and then the sun's radiation. You can see that that Etikopo TV can help you detect the microwave background. The better experiment is when you move onto the moon. That is, moving away from the radiations that's the signals, radio signals on Earth, and then the radiations of the sun. You can still detect that cosmic microwave background, which is the relic evidence that the universe began from a hot and dense infinitesimal point. And so, this further gives us evidence on the observational side. So we are looking into the stars, using radio telescopes to hear the universe, to see the universe, to peer into the universe and know what's actually happening there, and to make conclusions on that. And so we explain these forms of evidence in terms of the Big Bang, telling us about the origins of our universe. And these aren't experiments, these aren't observations that can be disputed, because the relic radiation has been measured to immense accuracy, for about 99.9997% accuracy. And so these aren't observations to be contended with. And that was just after 380,000 years after the Big Bang. So you see light. Now light as we know it is of several forms. We see visible light, but it is not only visible light that is out there in the universe. There are several forms of light, from high energy light, which are gamma rays, moving to X-rays, to UV, to the visible light that we can see in, to infrared, which we cannot see, to microwave, and then radio waves. And it keeps going that way. And so, at the initial stage of the universe, it was very hot and dense. And so, high energy particles were released. But because the universe expands, those high energy gamma rays had to be redshifted. That is the wavelength, which is looking at the cone. If you are to Google it, so we are like in a science lab where we are trying to experiment with these ideas. The cone, if you look at it, the very tightly packed ones are highly energetic, and the very loose ones are of low energy. So in the early universe, you would see orange. That is radiations that are highly energetic. And due to the expansion of the universe, those high energy particles of light had to stretch, and now we see it in the microwave. So you can see from the gamma ray to the microwave, it's a long way, and that tells us about the universe as well. That aside, we see, that is experimenting, we see other physicists coming up with brilliant ideas and proposing theories. One of them was the Big Bang nucleosynthesis, which is also another pillar of the Big Bang theory, about light elements that form in the early universe. So after the universe expanded, you have heard me mention that it expanded from an infinitely hot and dense point. After it expanded from that point, it cooled down. It cooled down to enable particles to form, and as they formed, this theory tells us about light elements of the universe. And we look at it, and it is of high precision. Hydrogen, neutral hydrogen atoms, that is from primordial deuterium that you can see in quasars. Quasars are galaxies with their black holes being active. So at the center of our galaxy, which is the Milky Way galaxy, there is a black hole. We will explain that, and we will get an idea of a black hole. And a black hole at the center of galaxies, and that's what we observe. That black hole is active. If that black hole is active, it means that it is consuming materials. Yes, and it can shine bright, very bright, than even really big galaxies than them. And we find imprints of these primordial deuterium, lithium, neutral hydrogen atoms scattered across. Even in our own Milky Way, we find all these things about light elements in the universe. And these are precise observations supported by the maths and the experiments to speak for the Big Bang. And to talk about the accuracy of the Big Bang, I want to reiterate and emphasize that the matter that we are discussing today is about science. It's a question for the science, the natural science. It's not a question for philosophy. We are not here to philosophize and then share, ideas from our homes and our minds. We are here to demonstrate and prove, show what is out there. So we see all the things that we have looked at so far are observations looking far into space. Now, I have not commented on the distances in space. I've not commented on the distances in space, but the distances are very, very big. And so right here on Earth, we have to create experiments, because if you come up with a theory, it should be well supported. It should be ironclad. There should be evidence supporting it. And the machine that we have created on Earth is the Large Hadron Collider at the European Organization for Nuclear Physics, between the France and then Switzerland border. And they fly particles at high energies, smash them together, and break them to test the theory of the Big Bang. And what do they see? They see that at high energies, when we accelerate particles, we can go up to 10 to the minus 13th of the Big Bang. That is, take a second. The smallest portion of a second, 10 to the minus 13th of a second. Right now, as we speak, there are experiments that have been documented in scientific journals about the temperatures that were present at the Big Bang, and then the energy levels. As we speak, we are using energy levels about 7 trillion electron volts, producing energies really, really high. And these are testing the theory and giving us accurate data about the Big Bang theory. And so we find out that we can also tell the things that make up the universe. And we see that the universe is made up of dark energy, which is something that scientists don't understand. But we see its effect. That is the expansion of the universe. Basically, something is pushing the universe into chaos. It's moving galaxies away, galaxies that are not gravitationally bound, like the Milky Way galaxy, which is gravitationally bound to the Andromeda galaxy, which is 2.5 million light years from us. Now, the concept of light year is one that is mind-boggling. That is this: if you should take the speed of light to be 300 kilometers per second, and we use our own sun, it takes 8 minutes from the sun to get to us, light emitted by the sun to get to us. So you move it forward to an hour. So as we speak, if, say, an alien civilization comes and picks out our sun, it will take 8 minutes before we feel the effect. So when you see the sun, that was the sun 8 minutes ago. So we can use that same technique to look at distances in space, because these distances are vast. And we see that the universe is made up of 70% dark matter, 25% dark energy, and 5% normal matter that you and I are made out of. You and I are made out of these particles. And so, a summary of the Big Bang. Basically, what we are saying is that the Big Bang began at an infinitesimal point, a hot and dense, where all the forces, the fundamental forces, the strong nuclear force, the weak nuclear force, gravity, and electromagnetism were fused, something that some theorize as a super force. And then these forces broke apart as the universe expanded and cooled down, enabling matter particles, fundamental matter particles, as we test in our Large Hadron Collider, being quarks, to form, bound by this strong force. So as the universe expands and cools down, it enables these particles to be bound together. And the process moved on until 380,000 years, about that time, where the universe had cooled for neutral atoms to be formed, neutral hydrogen atoms to be formed. That is when the relic cosmic microwave background was released, that we see 13.7 billion years ago. And the universe entered into its dark ages. And shortly after that, that is, in terms of cosmic time, the universe had to produce stars. So hydrogen gas condensed, formed stars. These stars exploded, expelling their materials into the vast expanse. And the recycling of these materials formed the core of galaxies. So our Milky Way galaxy is about 13 billion years old. And our solar system, as you would find if you Google it, you can check credible website like NASA, Google it, and then you would learn that our solar system is about 4.5 billion years. And these are things that you can calculate. So it tells us that the mass check with the observations and the experiments as well. And then a few misconceptions about the Big Bang. Now, when we hear Big Bang, people talk about something originating from nowhere. That is not what scientists are saying. The infinitesimal points where everything came from, we need a better theory to understand it. The Big Bang is an extrapolation of Einstein's equations of general relativity. And so it is a classical theory. It is not a quantum theory. That is why in our particle accelerators, we are trying to go into the quantum. So you realize that as we discuss these issues, we will not be introducing matters of intuition. Yes. So this is basically some misconceptions. The Big Bang, it didn't appear out of nowhere. There was a point where we are trying to explain. And then it wasn't an explosion in a normal form of explosion. Normal form of explosion, there's space. But here, space was contained in that point. And then the universe does not have a center. The Big Bang happened everywhere. The Big Bang happened everywhere. So these are a few misconceptions with people who do not want to do the science. People who do not want to do the reading and the research. However, I believe that as we progress as a civilization, we would find out these ideas. So basically, we make a few conclusions. That the universe as our ancestors saw it were just gods and creation myths. Modern cosmology tells us from evidence.
Thank you very much. We thank our brother Marcus very much for this great exposition. It's just supposed to do. I would encourage all our viewers to share this program for other people to also have the chance to learn and to be educated as well. I would also encourage you to send your questions so that during the questions time, you would be able to ask for you. You would quickly move to our brother Derek Danso so that he would also come in with his exposition. Let's welcome our brother Derek Danso.
Okay, thank you very much. And if you are watching us from Ghana, good evening. Wherever you are watching us from, good afternoon, good morning. It's indeed a pleasure to discuss such an important topic as this. We are discussing origins of the universe, creation or Big Bang. And you listen to my good friend Marcus. And if you listen to him carefully, you would hear a lot of assumptions. And I hope that within the few minutes ahead of me, I'll be able to unpack all the errors that he just spewed out. So please stay with me as we note this. What are we discussing? This is a very important issue. Why? Because it defines everything that we are, that makes us who we are as humans, and everything about us. This particular discussion really covers it. Let's move to the way I will be presenting my statements today. First, I'll state my position clearly, then I'll look at the definition of terms. Yes, I'll give the evidence for the Big Bang, then clearly I will show you that the Big Bang never happened. Alongside us, I show that the creation model is true. So let's look at the first one then. The first one I have here is this. This is my position. Creation is the only explanation for the origin of the universe. What do I mean by this? Please, let's look at the next slide. What do I mean by this? When I talk about origin, what do I mean? Marcus went on and on and on without really giving us any proper definition of terms. And Marcus said today we are not going to talk about, it's not a philosophical discussion, it's not an intuitive discussion. But what did Marcus just do? All the science, all the calculations that has been done, can you do that without intuition? Can you do that without logical reasoning? And I will be asking him during the cross-examination. You can't have that, so it's actually false. So please just hold that in mind. That is false. When Marcus says that you don't need intuition here, you don't need we don't need to apply any philosophical statement here, it's false. Well, he used a lot in his own statements. Why? And he's not being consistent. That's what I'm trying to say. And I will show that throughout my presentation. Now when we talk about the origin, this is what I mean. The point or place where something begins or is created. That is to say the source or cause of something. And so when you hear the topic, origins of the universe, what caused the universe? That is the proposition for this conversation. And my point is that the universe was created. And his point is supposed to be that the universe was not created, but rather the Big Bang is the cause. Now when I talk about the universe, what do I mean here? By talking about the universe, I am referring to the whole cosmic system of matter and energy, of which Earth and therefore the human race is part. So when I talk about the universe, you are part of it, I am part of it. So when we talk about the origins of the universe, everything that you know of, and Britannica helps us by adding this further information. The people, places, experiences, our emotions, love, hatred, all these things, we find them in the world. And these are immaterial stuff. These are not material stuff. So things like the earth, things like we human beings, we are the material entities within the universe. But when we look at things like love, things like emotions, things like logic, the laws of logic that we are using here, the laws of logic that construct science, when you look at it carefully, all these things are part of what is called the universe. So when I define, or when I say that, please let's go to the previous slide. The previous slide. Yes, my first point, please. The clear list. Yes. So when I say that creation is the only explanation for the origin of the universe, this is what I'm saying. I'm saying that creation is the only explanation as to how you and I got here. Creation is the only explanation as to how we have these emotions in the universe, as to how we have these logical principles and laws in the universe. How do we have these? He mentioned the Hubble law, and we'll get there. How do we have this law without actually having any being creating it? Did it just happen? And we'll look more into that. So please, let's go on. And that's not the only thing in the proposition. Another thing in there is creation. So when I mention creation here for this particular conversation, this is what I mean. The act of making or producing something that did not exist before. So in other words, my position here is that creation is based on what the Bible actually says. So what the Bible says, that is what I am. That is why I'm basing my argument and my point from. And it's going to be very interesting during the cross-examination. So this is what I'm saying. Creation is based on the Bible, where God created the universe and everything in it as described in Genesis. Now he created the heavens and the earth, fully formed and functioning in 6 literal days, about 6,000 years ago. And we have a lot of evidence to back this. Now, the context of Genesis, that's chapter 1, as well as other places in the Bible, make it clear that these days were ordinary 24-hour days. So in order for this to hold, then the Bible in its entirety must be proven to be true. If we find, historical errors, when we find problems in the Bible, then we can make an argument that that is not the case. But yes, the Bible has been tested, it has been proven, and I hope to explore it when he brings that up later on. So let's move on, please. Now, what about the Big Bang? It's another point, a term within our discussion today. When we talk about the Big Bang, he actually mentioned a bit about it. And he went further without actually looking at the details of the Big Bang. And I'm not surprised because he's not a science guy. So, and I'm not going to pardon him for that. He should have actually done the research before this. So I'm sure he did. So he knows about it. Now look at what the Big Bang says. It is the theory of the evolution of the universe. We call this cosmic evolution. What we have for evolution of life, what many people are aware of, is what we call biological evolution. But the Big Bang is an evolutionary model. And it simply says that it's a naturalistic way of looking at everything. By naturalistic way, that is to say that there is no external being moving all the things around. So, like the formulas he mentioned, anything that the Big Bang, according to those who hold on to that view, anything that it comes about is just unguided process, random chances. Now let's look at this. It is essential. It is an essential feature. Its essential feature is the emergence of the universe from a state of extremely high temperature and density that occurred 13.8 billion years ago. And you can see temperature and density in red. Why? Can you have temperature without matter? Can you have density without matter? Feel free to check. Can you have density without matter? So if indeed he admitted to it that the Big Bang actually emerged from an extremely high temperature and density, what do you mean by that? That means matter was already there. Is that what you are saying? But according to him, we have the other heavy elements and other elements being created later. Contradiction, self-contradiction. To spot any false theory, to spot any false concept, please look at the inconsistencies. Now let's move forward. According to the Big Bang model, the universe expanded rapidly from a highly compressed primordial state. And he was telling us that the primordial state is right now, we don't have an answer, so we shouldn't care. Let's take our time. Why should we take our time? You are telling us that the debate topic is the origins of the universe. Everything, the origin of everything. And yet, you are telling us that what that primordial soup is, you don't know how it came about. Then you have failed the proposition. Then you have not actually kept to the topic we are discussing here today. Now look at this. It says, which resulted in a significant decrease in density and temperature. Now, please let's move to the next one. Look at what PBS, and I know it's one site that Marcus likes to go to. PBS.com, this is what they describe concerning the Big Bang. It says, the universe began with a vast explosion. And Marcus said that one misconception about the Big Bang is actually that it didn't explode. Then you fight with your colleagues. Yes, he says that it's a vast explosion that generated space and time itself and created all the matter and energy in the universe. So this is what we are saying. According to the Big Bang model, the entire universe, the entire matter and energy itself was actually begun by the Big Bang. So if that is the case, the question is that where did that energy come from? How could the Big Bang occur without energy? It needed energy. Yet, according to PBS, Big Bang created all the matter and the energy in the universe. So the love we find, the hatred we find, anything immaterial should be explained by the Big Bang model. But I will submit to you that it can't. Why? These are observational things. We see them every day. We relate to them, yet the Big Bang doesn't give us any explanation for it. If the Big Bang explains it, he should help us. And he just mentioned that he's trying to write it off because this is not a philosophical conversation. Really, we will get there. Now, this is an interesting thing that PBS added. Exactly what triggered this sudden expansion remains a mystery. No, it doesn't remain a mystery. It's because you're holding on to a false view. Now, astronomers believe it involved a runaway process called inflation. And we would explore that a lot because almost all the supposed observational facts that Marcus mentioned directing us towards the Big Bang, actually, without the inflation, those explanations will not hold. Those explanations will not hold. In which a peculiar type of energy that existed in a vacuum of space was suddenly mobilized. As to where the inflation is now, we are told that at a point it ended, so it's no longer here. Now, this is my question. Look at the next statement they make. The inflationary expansion ended only when this energy was transformed into more familiar forms of matter and energy. The question is this observable? Marcus was all over the place right now telling everybody watching that, yes indeed, the Big Bang, we are here, and let me quote him. This is what he said. He said we are here to, he meant, yes, theoretical, we are going to give theoretical evidence, observational science, experimental science. Marcus, I'm asking you, is the Big Bang an experimental fact? Is it something we observe? Can it be repeated? Can it be observed? It cannot be done. So therefore, the Big Bang doesn't fall within the class of science that you are even describing. The Big Bang, even if it would be true, would fall under a class called historical science, not observable science. No. And during the course examination, Marcus is going to show us which experiment tells us that it has been observed. Was it observed? He says observational science. Where is the observational science for the Big Bang? Where is the experimental science for? Where did we test it? It is not there, ladies and gentlemen. And the various pointers that he mentioned, we'll look at them in no time. So that was just by the way. Now, for the Big Bang to be true, these 7 things must hold. And without explaining these 7 things, we can't write them off. For it to be true, 1, the universe popped into existence, ultimately from nothing. And Marcus said that is one assumption people have. Please, you need to tell us, how did the universe come about? If it is the Big Bang, then it means it had to pop into existence spontaneously. We will look at the observational evidence we have today, whether it confirms that you can have things just popping into existence. Number 2, abiogenesis, that is to say, spontaneous generation of life. If the Big Bang is true, it should be able to explain to us how life came about. It is a matter of importance because we are saying that the origins of the universe, everything within it. Number 3, macroevolution. That is to say, moving from protoplasm to living organisms, from non-living things to living organisms. He needs to show us how the Big Bang does that. And I submit to you, he can't show it. He can't show it. And I say Big Bang because that, according to this debate, it is the origin of everything. So if you can't explain it, then it doesn't fit. It never happened, and it doesn't fit the information and the data we have. Again, neo-Darwinism provides the mechanism for macroevolution. That is, if Big Bang is true. Again, humans and apes have a common ancestor, and I hope to show that all this is false. All this is false. And you see, when he was speaking, he mentioned about the age and sometime 13.8 billion years. This is because for the Big Bang to hold that view, they need to use what we call uniformitarianism. And that is one thing that guides the ages and how they measure all things. It's a big assumption which is false. So it doesn't fit the evidence we have. It doesn't fit it. Now, the universe and life are very, very old according to the Big Bang model. Now, let's look at what the creation model says. If the creation is true, these are the 7 things you should be looking for from the creation. Number 1, the universe was created by a non-physical being, entity, that is God, outside of the boundaries of this physical universe. Number 2, life was also created suddenly by that being. Number 3, all present kinds have remained constant since creation. So for Marcus to show that the creation model is false, he should refute any of these 7 principles. And that will be at the end of the debate. But he can't do it. He can't do it. Now, the very few ones I'll mention here is that the universe and life are relatively young. And we'll look at that as well. Now, let's go ahead. Now, when we look at this, the law of rationality, looking at the 2 principles, if you are listening to us, whether you are an atheist or whether you're a Christian, whichever your position is, we need to apply the law of rationality. We need to apply the law of rationality. We can't ignore this. What is that law of rationality? You only draw conclusions based on the evidence available. That is what you do. And Marcus is telling us that the Big Bang confirms these things. But for the Big Bang to have occurred, then we should observe things popping into existence out of nothing. I mean, relatively nothing or ultimately nothing. Do we observe that? Let's look at the evidence that is available. And one good atheist, who was a proponent for a long time, says that to be irrational precisely is to refuse to consider relevant evidence, although knowing it to be relevant. To accept one position while refusing to accept its plain logical consequences. And he's here saying that you don't need to apply philosophical. How do you do math without philosophy? How do you do math without logic? You can't. So let's look at the point. Now the evidences. Creation account makes absolute sense. Why? Because of the law of cause and effect. This is an observable thing. Everything around us, every material effect must have an adequate antecedent cause. Is this true or false? It is true. That law of cause and effect, it's a law. It happens every single time. Do we have effects without adequate causes? No, we don't. Then you are veering into what you call the supernatural. And that is my claim, saying that the creation model is a supernatural event. God, the cause, created this universe. Marcus is saying that no. If you conjure the God into the situation, then you are going to be like our ancient ancestors. I mean, they assume this position. No. Yes, they assume that position because it's true. Why is it true? We have an effect, that is the universe. There should be a cause. What is Marcus's response to this? The Big Bang. The Big Bang brought everything into existence. Really? How did the Big Bang do this? Marcus says, really, I don't really know what was there before it started, but all I know is that it just began. Really? Really? That is not a good way of... And he says he's actually doing science. By that, he is doing science. When you reject the evidence that there's an effect, that's what he's saying. Now, this is the cause for the universe. The cause for the universe is an infinite, uncaused, eternal, omnipotent, omniscient, non-physical, spiritual being. And that is what my position today, I'm arguing from the Bible. Okay. And the Bible argues that clearly, and we hope to show that if you have an alternative view, please present it. And here in this debate, Marcus says it is the Big Bang, but the Big Bang is not an adequate cause. Therefore, he is going against what he even calls science. the Big Bang is not scientific, so he shouldn't be saying that. Now let's look at the next thing. Now with spontaneous generation, let's ask, this is another law. We see, do we have things popping into existence? No. Laws don't just pop into existence without a lawmaker, Marcus. Laws don't just pop into existence. Do they? If they do, please prove it to us. And I'm sure you have given us a lot of, you have mentioned a lot of scientific people. Yes. Has any of them disproved the law of spontaneous generation? Yes, it has been disproved. How? We will look at it. When Paul Davies wrote in The New Scientist, and I know you should accept The New Scientist if you hold on to your position. He says this: how did stupid atoms spontaneously write their own software? And question you need to answer. Why did he mention stupid atoms? I mean, if there is no creator, it makes no sense. Nothing makes sense. Why should something make sense? Why should you think something is bad and something is? Why should you think the concept of even the laws of physics themselves? Who wrote those laws? Look at what he continues to say. In a more extensive discourse on the subject, he says this: where do these laws come from, and why do they have the form that they do? This is a very important question. Where do the laws come from? Because if out of random chances, assuming I have a balloon here, and that balloon just explodes, are you expecting something uniform coming from it? If I pick Marcus's phone, drops it to the ground, breaks the phone, are we expecting an order to be formed out of that? No, we don't observe it with all due respect. We don't. Therefore, it simply doesn't happen. Now let's look at the next thing. The next thing that refutes this is the first law of thermodynamics. And I place this here because Marcus really likes to talk about this. In most of my presentations, when Marcus comes to the comment section, one thing that he has highlighted, and I think, I don't know the various places, but he has highlighted is that the law of thermodynamics has been refuted. And today I will demand how the law of thermodynamics has been refuted. I have an evidence of my conversation with him where he actually says that the law of thermodynamics has been refuted. And that really shows that he doesn't really understand the science that he claims to know. He doesn't. Because the first law of thermodynamics has not been refuted. Energy can neither be created nor destroyed, but can only be converted from one form to another form. Now let's look at the next slide. This is from the thermodynamics textbook. And when you look at fundamentals of thermodynamics, and if Marcus has ever sat in any physics class before, he wouldn't have made that statement. Why? The basis of every law of nature is experimental evidence. Marcus, where is the experimental evidence for the Big Bang? Do we have the experimental evidence for the Big Bang? No. The best we have effects around us. Tell us how they came about, and you claim that spontaneously particles pop into existence. That is not science. That is faith, and actually is blind faith. Now, it says that the base of every law of nature is experimental evidence, and this is true also of the first law of thermodynamics. Many different experiments, Marcus, many different experiments have been conducted on the first law, and everyone thus far has verified it either directly or indirectly. The first law has never been disproved. But I have Marcus, I have evidence of it, our conversation, he telling us that the laws of thermodynamics have actually been refuted, which is completely false. Inconsistencies. Now let's look at the next thing. Now, spontaneous generation, we have seen that it can't give rise to life. Remember, one of the things for the Big Bang to be true is that how did life come about? It can't explain that, and this is why. This is an experiment that shows that was false. Please, let's look at the next slide. This was done by Louis Pasteur when he placed concerning to verify that is it true that we have can life just pop into existence? Can we have matter just pop into existence? And he verified that is false. It is not true. Unless the supernatural does it. And that is my position, that the supernatural did it. God. But he's saying that no. He's rejecting that view that no, the supernatural can't be true. But rather the naturalistic way is true. If that is true, what is your evidence? The Big Bang never happened. It's not true. It's not true. Now let's move to the next. Now the law of biogenesis has clearly been shown to be true, that life comes from already existing life. You can't have life coming from, as Marcus would go, stars. It's not true. It's not true. Now, please move to the next slide. The next slide. I want to read something out here. And Marcus, you may have a copy. Please, you may pass it to Marcus. Yes. Please, we'll come back to this so you can. Yes. So, this is a document. Actually, it's a peer-reviewed paper. And before we had this debate, when I first challenged Marcus to have this debate, he told me that I should provide him with peer-reviewed papers of people, of actual scientists who have written papers against the Big Bang Theory. Please, you have in your hand over 250 scientists, over 250 scientists who have actually documented and refuted that the Big Bang Theory never happened. Now let me read what they said. He says this: the Big Bang today relies on the growing number of hypothetical entities, things that have never been observed. Example, inflation. You heard Marcus mention dark matter. You heard him mention dark energy. Are the most prominent examples. Continue reading. Without them, there would be a fatal contradiction between the observations made by astronomers and the predictions of the Big Bang Theory. In no other field of physics would this continual recourse to new hypothetical objects be accepted as a way of bridging the gap between theory and observation. It would at least raise serious questions about the validity of the underlying theory. These are over 250, and this list keeps on increasing. You can go and check, and I'll provide this PDF. You can look at it. He has it. And the statement goes on to say this: but the Big Bang Theory can't survive without these fact factors. So he mentioned, he showed you cosmic microwave background radiation. During the rebuttal, I hope to talk about it. And I have another research paper here that I will give to Marcus after we are done. That actually shows him that he doesn't actually understand the concept of the Big Bang. It never happened. It's a hypothesis. It doesn't qualify to be called a theory. It is a model. It is a model, and it's false. It's a false model. Now, to conclude the statement, he says this: what is more, the Big Bang Theory can boast of no quantitative predictions that have subsequently been validated by observation. Is Marcus a scientist? No. Does Marcus get to the field and do the research himself? No. Do I go to the field to do the research? No. But of course, I have studied physics in depth, and I'm doing an MPhil in physics. But that is not the point here. The point is that you have over 250 physicists and other scientists who have written, who have come together to say, no, there are massive problems with the Big Bang. Let me mention some to you. One, we have some problems like the flatness problem. And when I get to the rebuttal, I will mention about 15 examples to you of the problem that the Big Bang has. The Big Bang never happened. And before the Big Bang came, the steady state theory was there. He mentioned the expansion of the universe. Yes, the steady state theory also talked about expansion. And so that is false. The Big Bang never happened. Thank you
very much, Brother Derek Danso, for your great exposition as well. We thank you so much, our viewers. I believe you are still with us, and you are also taking note yourselves, and you are listening attentively. Now, both parties have presented their cases, and I would like to remind you again that this debate is about the origins of the universe, creation or Big Bang, and that is the topic our brothers are debating on. And we are having our brother Danso arguing for the creation, and our brother Marcus Imbro arguing for the Big Bang. Both of them have presented their opening statements, 25 minutes each, and now we move on to the rebuttal section. I would encourage you to share and also submit your questions in capitals so that you can read it when it's time for questions. Straight away, we move to our brother Marcus Imbro for a 10 minutes rebuttal.
Thank you very much, Seth. That was quite entertaining. I was here laughing my lungs out. So I'll move straight into it, and then we'll find a few interesting things to talk about. Now, the scientific community is one that is interesting. I find it a fulfillment for scientists to do their research and then find incredible precision with their theories. Moving straight to what our brother was trying to do, there are lots of fallacies that he is just trying to put in there. Let me just list them. I will not have the time to explain, but clearly you can see he doesn't have any explanation on how creation happened. So he's obsessed about the Big Bang, and probably me quoting conversations and trying to create a false narrative here about me, discredit me before you that I am incompetent to present the matter. But what is more fulfilling about the universe and how it tells us is that there are lots of information there, and you don't need to be a scientist as he doesn't need to be an accountant to appreciate the concepts in accounting. So I don't need to be an accountant because I have reliable sources to run to. That is why I would encourage everybody joining us today to go out there. There are lots of YouTube channels, lots of scientific journals out there. Go and be curious. Do the research yourself. Read. And then let's see what happens. So, the fallacies that he made. God of the gaps argument. He was strawmanning. Basically, I was waiting. The reason why I was so enthusiastic about this debate is because I wanted to find out creation physics. I wanted to learn how the creation happened. I wanted him to give us some propositions so that we can test it. 6,000 years old. That was one prediction that he made. Even in my presentation, I mentioned it. There are rocks on Earth dated to 4 billion years. Rocks on Earth with radiometric dating methods. Of course, he wants to discredit the scientific community. That's his approach. That is why you won't find him talk about creation. But I wanted us to go into the Bible so that he will make propositions. For instance, the earth forming before the sun. And then he will render an explanation. And then give us an experiment, an observation of that. On my slide, I put on something about the formation of stars. Now, star formation is something you can Google about with me, and we can even discuss it now. Star formation is very simple. It's all about our sun. It's all about the primary star, and then the remnant of the formation of the star forms the planet. So our sun constitutes 99.8% of all mass in our solar system. You add from Mercury to Pluto, if you are counting it as a planet. It has been demoted, of course, to a dwarf planet. If you are counting all of them, they constitute only 0.2%. Together with the asteroids, together with the comets, and all the chaos out there, all these constitute only 0.2%. So it's just about the sun. We look out there, and then we see the same thing happening. So we can assume, and we can even make emphasis based on our observations that these things can be explained with the laws of physics. So everything around us basically is governed by the laws of physics. That is what I wanted to see in his presentation about creation physics. I wanted to see how the sun came after Earth. I wanted to see how human beings were made out of dust. I wanted to see so that scientists could pick up these ideas, experiment them in their labs. We are going into our labs. I would encourage you. We are wearing our white robes, going to the lab, and we are drawing up experiments, right? That is what I wanted to see. But basically, he talked about my position, and he mischaracterized everything. So I encourage you to just Google it, go online, go on YouTube, just put in a few words, and then you can also, there are lots of things that I cannot explain. Obviously, the time is very small. So you do the research, and then you will also find some very interesting things about the universe. What saddens me is you being in the universe and not learning about it. Planetary formation, as I mentioned earlier, is something we can observe happening in ionized molecular clouds out there, very close to us. The Orion Nebula. You can use telescopes that we have built. Obviously, our eyes are highly inefficient. We can't see shorter wavelengths of light, like radio waves. We can't see. Only the visible spectrum. So we have to build machines to see these things. And not long ago, the Hubble telescope saw a star forming in its early days, right? And planets like planets forming, a Jupiter-like planets forming around that star, and we can see it happening. We can see it happening, and these are published in scientific journals just to inform us. So these are the things out there that I am here to encourage scientific curiosity. That you go out there, you do the research, right, and then we see what happens. I am still waiting for him to explain to me creation physics, because most of the things that he talked about are just mischaracterization of scientific ideas. Let me just go into some of them so that we see. Did the universe, I even wanted to ask him, did the universe exist before our solar system? Of course, we can look at the transition. The universe, our galaxy, and then our solar system. And then we watch it in time. We watch it in time. Of course, time is relative, according to Einstein's theory of general relativity. and then we can look at that. So at the point, at the singularity, that's the Big Bang singularity, the point of infinite density. Of course, scientists don't know. That is why we are probing the resources to produce high energies and high temperatures of that sort. Even if we build a particle accelerator as big as our solar system, we will not be able to replicate that. We would have to build a particle accelerator as big as our observable universe, which is about 92 billion light years. These are interesting facts about the universe that you can find online. 92 billion light years away. And these are the things that we see. You look into it, so that's not even the entire universe, because as we speak, about 94% of galaxies that we perceive, they have receded from our horizon because of the speed of light. Now, I don't think as a physics student, he would disagree with me that the speed of light is finite. Now, if the speed of light is finite, and I was able to demonstrate that you can see the time from the photons that were emitted by our sun taking 8 minutes to reach us, we can see that, we can look back in time. So when you see a star in the sky, you are looking back in time. Basically, you are seeing the star as it was proportional to the distance of that star. And we use light years to measure distances. Now, light year, 300,000 kilometers per second. Convert it to an hour. If you drive, it is about 1 billion kilometers per hour. Of course, we can't get that fast, right? Yeah, so we use that to calculate distances, and these distances are very vast. So when it comes to the universe, we are talking about big numbers. He talked about, where we observe things popping into existence. I don't know, as a physics student, you should be familiar with virtual particles. You should be familiar with matter and antimatter particles popping into existence due to excitations in the field, in space, basically popping into existence and annihilating. We observe them; they are practically tested, and they are robust as you can have it. I think he's aware of that. So basically, I just want to emphasize that whatever that you see around us, they are the laws of physics. He neglected his whole creation narrative to come and talk about Big Bang, and he hugely mischaracterized it, trying to score a point. No, that's below the belt. You don't do that. We are having a discussion. You make your hypothesis. You recommend experiments. Oh, God created it 6,000 years ago. This is how he did it. And then we go to the lab, and then we check it there. That is what we want to see. Observations. You will look into the universe, and then we should see. I can just disprove one of his claims. 6,000. Andromeda galaxy is just 2.5 million light years. You see it. That is the time that the lights are emitted from that galaxy gets to us. 2.5 million light years. How many years would that be? 6,000? Even the black hole at the center of our own galaxy. How many years did we even take to figure it, and of what distance? So we can even use light to tell time in this particular discussion that we are having. So let me just. Einstein's equation tells us about the equivalence of energy to matter. So he making arguments about matter popping into existence. He probably should read on Einstein's equations of general relativity. And basically, I didn't get anything to speak about his creation narrative, just the age that he gave us, and then so that would be my rebuttal. When he decides to talk about his creation and then show us how it happened, that is when I can, bring in the science to explain whatever is happening there. So I'll just wait for him to bring his creation narratives and make claims that we can test scientifically.
Thank you very much, our brother Marcus Embro. That was a wonderful presentation by our brother, and that is the rebuttal from our brother in this debate. Without wasting much time, we move to our brother Redanso for his 10 minutes rebuttal. I believe that our audience are listening, and they are very, very attentive and watching. Be very objective about what is going on. It's very educative, and I believe that it's going to help us all. I beg with you to send in your questions, because I'm seeing nothing here. So please send in your questions and make it in capitals so that we can read.
Oh, has my time started? Okay, so ladies and gentlemen, with all due respect, we are here to actually, Marcus is saying that I'm actually misrepresentative, and I would like him to show me the misrepresentation. Where did I misrepresent the Big Bang theory, the Big Bang model? Where did I misrepresent it? And he went further to say that Google it, and I encourage you, please Google it. He was the one who mentioned that we are here to look at theoretical science. We are here to look at observational science, to look at experimental science. Does the Big Bang show us any of that? Is the Big Bang observable science? Is the Big Bang experimental science? If the Big Bang is an observational science, according to Marcus, Marcus should sign up to be a scientist and win a Nobel Prize. Because the Big Bang is not an observational science. You see, he is saying that if you are not an accountant, yes, you can go ahead and study accounting and understand accounting. Yes, that is if you study accounting well. If, as a physicist, if I want to know accounting, I don't go and study from the people who understand accounting well, and I just go online and just do copy paste and try to do online kind of work, I will not really understand accounting. That's what Marcus just did. Because when we look at the pointers, they are all wrong. Let me help you go through them. Number one, he mentioned redshift. Marcus, let me help you understand what redshift is. You see, when people go like redshift, where we have an expansion of the universe that proves the Big Bang, we need to ask certain questions. What is the redshift? You from your claim, it means that galaxies are moving away. But Marcus, that's not what redshift is. That is not what redshift is. Redshift is not the velocity of when you have the galaxies moving, the velocity of the galaxies, but rather in reference to the universe system, time, space. Space itself expanding, not galaxies moving. And if you understand the Big Bang well, you understand that according to the model, it is saying that if a galaxy is located at this point, everything is supposed to be uniform. The expansion was a rapid expansion. And when you look at the expansion according to Big Bang, today they're having a lot of issues. So they have to patch it up with what we call the inflationary model, which is an exponential speed or an exponential expansion of the universe. Why? Because what Marcus was saying about the redshift, that galaxies are moving away, it is rather a problem for them. So he doesn't really get what the redshift is when he says that it is the galaxies rather that are moving. No, it's rather the space itself is expanding. Space itself, and it's not a problem for me as a creationist. Why? I am saying that God created. So God created it. How did he create? It's all powerful. Do you get it? And when we look at the evidence, do we find evidence that confirms my model as a creationist? Yes. There's 6,000 years, and I'll give you the reference before I end this particular statement I'm making. Then Marcus went ahead to talk about the Hubble law. And during the crossfire, I would ask Marcus, is that a law? Did you check it? It's not a law. Laws don't change. But today, as we speak, we have two different values for the Hubble constant. We have two. So if you did the research, you would realize that there are research papers that are actually debating on this point. That no, you can't call the Hubble a law. And we have internet here. You told me that when we are coming for the debate, I should make sure we have internet. Marcus, the internet is here. Check it. During the crossfire, check it and tell me if I'm wrong. That we don't have two values for the Hubble constant. It's not a law. People used to think it's a law, but it's not. And you can check it yourself. Yes. Then again, Marcus mentioned radiometric dating. Who? Marcus. Radiometric dating. Diamonds. What is the age of diamonds according to the Big Bang model? Those who use the Big Bang idea that to date things, using the assumption that things are constant. When radiometric dating is used to date diamonds, it's dated to be millions of years old. But we find carbon inside the diamond. How old is carbon? The half-life of carbon is 5,730, if I'm right. 5,730 years. That is the half-life of carbon. But we find carbon within the diamond. That is supposedly, according to the Big Bang model, if it is true with the Big Bang assumption and the dating as the billions and billions of years, we shouldn't have carbon within the diamond. This is observational fact. Rationality, please let us use it. This is not Derek saying it. It's there. You can check. We have internet. You said it. Please Google it. And I'm encouraging you, Google it. Google it. So radiometric dating doesn't help your case. It doesn't help your case at all. Now let me use that opportunity to talk about my case with the age that I mentioned. Let me actually read out a research work that was done. concerning this age of the universe. Doing the crossfire, I will do that, else my time, it will take my time. Now, for the radiometric dating to hold, and I find a lot of people who think that when he mentioned distant starlight, you call it a distant starlight, concerning if you measure distances from here. Marcus made some assumptions. His assumption was that, like you are in your house, you can even do it in your house. No. When you are looking at astronomical bodies like what we are discussing, then you mentioned Einstein. There's something called time dilation. Time dilation. What is that time dilation? Time contracts and expands. According to you appeal to Einstein, so I should think you accept Einstein. Time dilation is true. So yes, it can explain that factor that why do we have distant starlight here today? And I don't have an issue at all. It doesn't prove that, okay, like you said, okay, it took 8 minutes for the light to move from the sun to get to us here. Therefore, if you are extrapolating it to the very far objects, then you are going to have it in millions and millions of years. I was surprised today you didn't bring up James Webb Telescope. I was really thinking you would bring up James Webb Telescope. The images from James Webb Telescope, if you have seen the research papers that are being published, check New Scientist, check Nature, check Science. These are best big papers. Check it and look at the new findings that are coming out. These images that we are seeing, they are rather matured universes. If the Big Bang is true, we are not supposed to see a matured universe because according to him, the light has been traveling for billions of years or for millions of years to get to us. So we shouldn't see a matured universe. We should a matured galaxy. We should see a galaxy that is now growing. If the Big Bang is true, but what did the James Webb Telescope see? A matured galaxy. Does that confirm Big Bang? No, the Big Bang never happened. Today, as we speak, there are alternative models that are coming up. One is the plasma model. The plasma model is another concept that is coming up, and there are so many scientists some scientists that are leaning towards the plasma model. It doesn't do any good thing for them. They should just come to creation. It doesn't do any good for them. Again, aside the plasma model, today we are having the new steady-state theories. Why? Because the problem the Big Bang has is gargantuan. And let me read this to you. He mentioned, he showed the image of the cosmic microwave background radiation. I don't know if it can be shown so that I will display something with it. The cosmic microwave background radiation that he proposed. This is an article that was not written by Christians. It was actually written by scientists who agree with the Big Bang model. And they are stating the issues and the many problems with it. Why did we reject the steady-state theory? Why did physicists throw the steady-state theory away and today we're having modifications of it? Why? Because even though it also predicted the expansion of the universe, so it's not only the Big Bang. Yes, steady-state theory, I'll prove it to you. Yes, so bring it in a crossfire. Yes, steady-state theory actually spoke about the expansion of the universe. And the steady-state theory, why it was rejected was that it says that the universe is eternal. Please, let's look at the cosmic microwave background radiation. Now, when you look at the background radiation, if Big Bang is true, these are the assumptions that they made. And I'm reading from A.D. Linde, and this person is a physicist. And she quotes all the scientists in this research paper. This is what she says. The homogeneity and isotropic problems of the Big Bang. Number one, he says, it was assumed that the universe was initially absolutely homogeneous and isotropic. Meanwhile, even at present, the universe is not totally homogeneous and isotropic. At least at a sufficiently small length scale, this means that there are no reasons for believing that the universe was homogeneous and isotropic. What is the point here? She continues in page 946, and I'll give this to you for your study after this. He says this. Unfortunately, however, as was noted by Guth, you know Alan Guth? Yes, the one who proposed the inflationary model to help solve the problems of the Big Bang. This is what he said. This scenario leads to some unacceptable cosmological consequences. According to this scenario, the field inside the bubbles of the new phase formed during the phase transition immediately grows up into an equilibrium value. Let me skip that and go for it. This will lead to an extremely large inhomogeneity and isotropy of the universe after the phase transition. Now look at this. Nevertheless, the main idea of the inflationary universe scenario was so attractive that many scientists extensively studied this scenario during the year after the appearance of the paper by Guth. The main results of this investigation have been summarized in the papers by Stephen Hawking, late Professor Stephen Hawking, and Guth, and it says, fortunately, in which it was concluded that the difficulties in the original scenario were insurmountable. You are here talking about the Big Bang happening. No. If the steady state theory was rejected, the same way this will be rejected, it goes ahead. Fortunately, at the same time, a new version of the inflationary universe.
Time up. Thank you very much, our brother Derek Danso, for another great and impressive submission. I believe that all our audience are also intact on their phones, their laptops, and any other means through which they are watching us. You are live in the studios of Chariot TV, and you are also live on Spotlight on the web. May I remind you again that this is a debate between a Christian and an atheist on the origins of the universe, creation or Big Bang. We have our brother Danso debating for the creation, and our brother Imbro Marcus debating for the Big Bang. We've gone through our opening statements, rebuttals, which just ended. We are moving on to our cross-examination. We'll begin with our brother Marcus Imbro. 10 minutes. Marcus, over to you.
Thank you very much, Seth. So, we've had an interesting discussion so far. So many mischaracterization going on, fallacies, logical fallacies going on. This, I would just advise you to do the reading so that we can focus on today's discussion. So, Derek.
Yes, sir.
Could you explain to us how creation happened? Okay. And give us any experiments that we can do or any observations. So when we look into the universe, for instance, I stated the cosmic microwave background. I stated the universe,
false, which was shown to be false.
Wait. Just follow the question. So just give us an explanation of how it happened. Because you were saying God is incorporated, it came from, I don't even know what you're saying. Just give us an explanation. How did it begin? How did God create? How did he do it? And how can it be replicated in the lab? Let's go.
Okay, thank you very much. These are some, if you listen to my presentation, well, Marcus, I stated clearly that my position, the origin of the universe, which is creation, is a supernatural event. Why is it a supernatural event? You can't take a supernatural event, you can't observe a supernatural event like the creation. Why? Because just like the Big Bang, you can't observe the creation event.
It created a material universe, so
yes,
there's some interaction.
Yes.
And our understanding of the universe is basically because of interaction. So you go to quantum, say an object that wants to have mass, it is interacting with the Higgs field. Light, for instance, doesn't interact with the Higgs field. That is why it is massless, and it can travel at that speed, right? So to travel at the speed of light, it means that you should be massless or you should carry infinite energy.
That's very true.
So if that is so, give me some propositions.
Creation
how?
Yes. So
give me some propositions.
In my presentation, I mentioned that it happened as the Genesis 1 says.
Okay,
so I just need to go to Genesis and read it out to you. Okay. So Genesis chapter 1, it says this. Genesis 1, verse numbered 1. In the beginning, God created the heavens and the earth. The earth was without form and void, and darkness was on the face of the deep, and the Spirit of God was hovering over the face of the waters.
No, that's our solar system. I'm talking about the universe.
No,
that's our solar system.
No, that is not the solar system. Maybe you don't know the Bible. Let me explain it to you. This is what the Bible. When the Bible says here in, you know that Hebrew language was used to write the Old Testament.
You go ahead.
And in verse 1 it says this. Bereshit bara Elohim et Yashamayim et haaret. The heaven used there is Yashamayim, not this skies you are seeing. The entire expanse of the cosmos.
Okay, so I get it. So if it is the entire expanse,
yes, sir,
and we are reading, and the earth came
yes,
before the sun.
Yes,
is that what's there?
Yes, that's what is there. The earth came before the sun,
which is directly against evidence.
That's not true.
Oh well, I quoted. Could you go to the slide, the last slide? Could you go to my last slide?
Okay,
Jonathan.
Okay.
Could you go to my last slide, Jonathan? Yeah. The time, the time.
Yeah, the time. What do you need on that slide?
Yeah, basically, I am showing you. Yeah, this is Hubble's observation of a solar system that is forming. That is what I mean by a solar system is a star and then a planet. And you can see what is denoted star there. The star symbol there is the star, and then the pointed thing, the protoplanet AB, is the protoplanet that is forming.
Wait,
so
can I ask a question?
Oh, wait. I am the one doing the questioning.
Right.
I'm the one doing the questioning.
All right.
So this is what we see, and it is everywhere. If you look into the Andromeda, I can give you several galaxies, and that is exactly what we see. The planets don't form before the star. Planets don't form before the star. It is all about the star, and remnants of the star form the planets. So here, your Bible is saying that Earth is it on the first day?
What?
No, it was Earth.
It says in the beginning, God created the heavens.
No, Earth. When was Earth formed?
Day 1.
Day 1. When was the sun formed?
Day 4. Not just the sun.
Oh, wait. The sun and moon.
Not
the sun
just
and moon.
The sun and all the other galaxies.
Okay, so in our solar system alone,
not just the solar system, the entire.
Wait.
You are asking a question.
No, the question is,
okay.
What is being referenced here is our solar system. Obviously, these people weren't astronomers to know. No. I understand the context, but let's put it in context. The people who wrote this talked about the Earth forming before the sun, and I just want to test that.
Yes,
I just want to test that. So, is that what we see? I am providing a counter evidence to what your book is saying.
Yeah.
So, explain to us the physics of a sun that forms after the formation of a planet.
Okay.
I want to know, how does that work?
Thank you very much. The assumption that, Jonathan, the assumption that underlies what you are saying is this. You are assuming that stars evolved, which is false.
Explain.
Let me answer the question.
Explain.
Let me answer the question. You are assuming that stars evolved over time. That is not what happened. For your assumptions to be true, you need to tell us how the Big Bang happened. The Big Bang never happened. It never did.
This is not about Big Bang. This is about your
image you are showing.
We are talking about this one. I would have to interrupt. Sorry.
Please,
I would have to interrupt.
Before it can become so convenient for us, let him answer, then you tell him.
No, he is moving away.
Yes,
he's
so let him
answering a different question.
So you stop him and tell him that he's moving away. So
he's moving away.
Or you want to...
Okay, no, it's just one. I'm just taking one claim
Okay.
for him to actually show us the physics.
Okay.
And clearly you can see that he cannot explain how it happened. Because basically, star formation, you have an ionized molecular
question.
No, wait, it's my time. So just let me.
All right.
You have ionized molecular clouds. They gravity pulls them together. They start cycling, and when the star is formed, consumes material, enough gas for that plasma that you see as our sun to form remnants. What I mean by remnants, a cheno, that is what collects as planets. And this is in our solar formation theory. We understand these things. So I just wanted to take one claim from your creation, since you decided not to tell us about creation and explain the physics to us. I just wanted to test one claim where we look at the formation of a solar system, because clearly that's what they are talking about. I don't see any reference to the universe out there, because obviously they didn't have telescopes like our modern understanding of the universe. Wait. Our modern understanding of the universe is clearly better than them. They weren't astronomers. These sources, I don't even know the person who wrote this. It is claimed is Moses. It doesn't claim authorship of this. And you have a lot of things going up here.
Is that a question?
Please, another question.
Officer, I should skip that one.
Yeah, because obviously you couldn't explain the physics, right? Do you agree that you couldn't explain the physics?
No, what happened? It was a supernatural event.
So how?
Yes,
how?
It's a miracle.
It's a miracle.
Yes. That is.
Do you believe in miracles?
I believe in miracles. That is what we mean by supernatural events.
Miracles happen now.
No, today.
Oh,
God is no longer doing miracles.
You have to be consistent. You are accusing me of inconsistency.
Yes.
Do miracles happen now?
If you
no, they don't.
If you ask
no, I want.
Let him answer. Okay.
Yeah, he's answering.
Yes.
He's answering.
Yes.
Are miracles happening in the universe out there for us to see planets forming before the star?
Okay, thank you. Can I answer?
Is a yes or no?
Can I answer?
Go ahead.
Thank you very much. So what happened with the stars?
Yes or no?
Oh.
No, you're consuming my time, Derek. You're consuming my time.
You want to
I don't know whether
no. Yes or no, and let's go.
Today we have what?
Yes or no? That's what we
don't have Adam. They don't have new human beings being created.
Do planets form before their stars? Yes or no? And let's move on to the other question.
Planets don't form before their stars.
Okay, so the star formed before the planet.
No. Pardon. I made a mistake. Let me correct myself. Please, let me answer. You're not giving me time to respond.
Let me ask the question again.
Marcus.
Okay, answer. Planets and star.
The planet, the Earth was formed, then the stars and other galaxies were formed.
My question
and
is,
it was formed through a miracle, just as Adam was created. Adam was created through a miraculous means. The evidence is that one we see design in the universe. No. So it points us back. So we don't have an observational thing. And let me explain. Marcus, now let me explain.
No, show. What experiment can we perform?
Thank you, Marcus. We don't have an experiment to prove something that is historical.
Well, that's fine. That's fine.
Yes.
You can give him the other minutes so that that's fine.
Yeah.
You can give him the other minutes so
that
I'm just done.
Okay. All right. So you have more minutes left, but
it's all right.
He said he's giving.
Yeah, I'm giving it to him. I'm giving it.
So let's move on straight to the Danso to also cross-examine our brother Marcus.
Okay.
10 minutes.
Marcus.
Yeah.
The first question I have to ask is this.
Good.
Is the Big Bang observable? Has anybody observed the Big Bang when it was happening?
Okay, you can't see. I
have it been observed?
What do you mean observed? We have recreated it in
just
a particle accelerator.
Marcus, just as you asked that with the creation, what do we have an experiment?
Yeah.
Like for the issue of creation,
that
says that yes, the Big Bang actually occurred and it can be observed.
Thank you very much. The cosmic microwave background has shown.
Okay.
You go back in time, it takes you to about 380,000 years after the Big Bang, showing that the universe moved from a stage of radiation into a state of matter, which I explained briefly. Of course, is enormous.
Okay, so thank you very much. That is an assumption. Why? Because it has been Marcus, please, it's my time. It's my time. If the Big Bang is true, then with the cosmic microwave background radiation, we are supposed to see uniformity.
Yeah, it's everywhere.
No, but that's not what we observe. And I quoted it to you. Marcus, relax. For the Big Bang to be true, we should see homogeneous atmosphere, or we should see the universe to be homogeneous and isotropic. But this is evidence. This is it. Please point the camera on me, please. This is the evidence. This is the physics research that has been done. And the names that are mentioned are Professor Stephen Hawking. It says that, you want me to go over everything? Yes, so the question is that the cosmic microwave background radiation you are pointing to is false.
Okay,
because it is not what you said is not homogeneous.
Let me answer.
Yes,
answer. Now, Robert Smolsing and then Anu Penzaz have already won a Nobel Prize on this.
Yes, they did another research on that.
They have won a Nobel Prize.
And what is the answer? What is the answer?
Right?
Yes, sir. Let's listen.
And this was even predicted before they observed it. And
what is the answer?
George Lemaitre on his deathbed was told that what you predicted, we have observed it experimentally through radio astronomy, right? And he was happy to die. He was happy because his theory turned out to be true. So it has been observed, and
this is the answer.
Someone has won a Nobel Prize on it. Do you know what that means?
What was the Nobel Prize? What was it about?
For the discovery of the cosmic microwave background.
No, you've not answered the question. You are just saying what was done.
It means that it has been seen because as I
explained, Marcus, please listen to me.
Okay.
You are not getting the question. The cosmic microwave background radiation you are talking about.
Yes.
If the Big Bang is true, it's supposed to be homogeneous.
Yes, it is.
But that is not what we observe.
My dear,
that is not what we observe.
When you point to that is true anywhere,
do you agree with the research or not?
This what you are quoting. I don't even know who you are quoting.
Oh, I just referenced it to you.
I don't know who you are quoting.
Okay.
So let me just explain.
Thank you very much. It's okay.
Okay, you go on.
Then my next question. Is matter eternal? Matter is eternal?
What is matter?
Anything that has matter can occupy space. Anything that is material.
Anything that interacts with the Higgs field and has matter.
Anything that is material, you ask me, I've defined matter.
What do you mean by eternal? Explain eternal.
It has always been there. It was never created. It has always been there.
Is your eternal related to time?
Please, it has always.
No, you have to define your terms.
Yes, and that is the explanation.
Marcus, during you had a time to ask questions. You didn't ask questions. So
your terminologies, I have to understand to respond.
I've explained what eternal means. Eternal means that forever. It has always been there.
Yes, that is the explanation.
That's my explanation for eternal. So it's matter eternal.
Well, when it comes to matter,
yes or no? I want yes or no.
What do you mean by yes or no?
That's what matter. Is it eternal? Yes or no?
You see, the reason why I was asking for his explanation of matter.
Marcus, please don't interact with Seth. You are the moderator, please. Marcus, interact.
Oh, you did the same to me. Okay, so let's.
Marcus, interact with me, not Seth.
Yes or no?
Please, yes or no?
And your matter is what? What do you explain as matter?
No, he has defined matter and eternal like you requested. So yes or no? Maybe the question.
If you're talking about fundamental particles, yes.
So
no.
I'm coming.
Yeah.
So matter is eternal.
Fundamental particles, yes.
Okay, thank you very much. So if matter is eternal, that means that the debate has been lost by Marcus. Why? Because the question of the debate is that origins of the universe. Are the fundamental particles part of the universe?
Oh yes, everything is quantum. Everything is quantum.
So it means that
everything is quantum.
Thank you very much.
Everything is quantum.
No problem.
No, do you agree?
Everything is relax.
Everything is quantum.
Relax.
Do you agree?
You have your time to ask questions. So Marcus, thank you very much. You just agreed that fundamental particles are part of the universe.
Yeah.
And the topic for the debate is that origins of the universe. How the universe started. Origin. And you have claimed, you have just admitted, can you point the camera to him? He has just admitted that the universe, the fundamental particles was there before it's eternal.
Why are you twisting the question?
No,
why are you twisting the question?
So,
no, did you listen to my answer?
Spontaneous generation.
He's mischaracterizing me. Is that what we are here to do?
Spontaneous generation. That is spontaneous generation.
No, we're not talking about evolution. We are talking about the universe.
Spontaneous generation.
What do you mean by that?
Spontaneous generation.
What do you mean by that?
Just popping into existence without.
Have you observed virtual particles?
You can't.
It's possible. It's possible.
It's possible.
It's possible.
What is the backing for that? You say what?
Virtual particles.
It's not true.
What do you mean?
What are virtual
particles? An experiment that was carried out.
What are virtual particles?
Let me explain.
Yes. What are virtual particles?
They are subatomic matter and antimatter particles that pop into existence because of the excitations in space, and we observe that with the Casimir effect, and that has been something that has been experimented with and done.
It is false. Particles.
Casimir effect. Are you saying Casimir effect is false?
What your interpretation Casimir effect is not what virtual particles does. Let me explain this to you, Marcus. You just said, I asked the question. You said, do we have particles?
No. Can you do some fact checking here?
Yes, you can. I told you can do it.
Moderator.
Marcus.
Can you do that for us?
Marcus. I asked the question. Do we have particles popping into existence?
Yes.
And the answer is that yes. That means that the law of thermodynamics has been defied.
Who says so?
Is that's what you are saying? If it pops into existence.
Who says so?
That's what I'm asking you.
Who says so?
That's what I'm asking, Marcus.
No.
Okay.
Who says so?
Who? It's my time up.
No. Who?
Okay. So Marcus, my next question.
Who?
Marcus, my next question. So you mentioned concerning the Big Bang.
Yeah.
If it is true.
Yes,
we are supposed to have how do we call it? It's supposed to give evidence for all the things that we see around.
Exactly.
Us. Yes. So how does the Big Bang account for the laws of physics in immaterial things?
What do you mean by immaterial?
Immaterial. The laws of physics are immaterial. Are the laws of physics not immaterial?
What do you mean by the laws of physics explain material things?
No,
so I don't know what you mean by immaterial.
In the sense of something like love. It's immaterial, right? So how does the Big Bang account for that?
Love is a consequence of biological things happening in your head. You feel attracted to somebody. It can be explained perfectly if we should move to biology.
Okay. It can be explained perfectly.
It can be explained
perfectly. Thank you very much.
It can be explained.
Okay, so Marcus, so your answer to the question of how we have all this, it can be explained in biology perfectly. I would want to see the research that says love can be explained. It's not true. How does the Big Bang?
Do you know neuroscience?
Yes, it's false. It can't. Now, Marcus,
who said that?
Please, we have your time to ask questions. Now, is my time up?
No.
Okay, so Marcus, the question is this.
Okay.
So, how do we have immaterial things coming into existence, like the laws of physics that I mentioned? They are immaterial. They are able to explain all the things that we see around us because they are immaterial. So, in the first place, do you agree that the laws of physics are immaterial?
What do you even mean by that? Because
they are not physical. That's what I mean.
They are just ideas.
Yes. So where do your ideas come from?
Our interaction with the universe.
That is false.
Do you say that is false?
Yes, let me explain.
That our interaction with the universe generates knowledge. What is science in the first place?
Information science has confirmed.
What is science in the first place?
Please, when you have your time, you ask your questions. Information science, Marcus, information science has actually taught us this. What has information science done? Information science tells us that information comes from mind. Do you disagree with that? Can you have information like DNA? You have DNA in existence. You have laws of it without lawmakers. You have laws without lawmakers.
What do you mean by law without lawmakers? Because when we look into the universe,
we have laws of gravity. We have laws of gravity. Can we have law without a lawmaker?
Well, gravity has evolved at the beginning of time. Which
evolved how?
I explained and mentioned the super force.
How did
the super force where all the fundamental forces were fused into one force?
How were they fused in one?
Yeah, because I just cited
how
experiments from form the Large Hadron Collider.
It doesn't explain it. How?
Let me just explain. So basically, at high temperatures and then at high energies, right, you get the forces merging together. So we have been able to merge electricity and magnetism.
Marcus, relax,
now we have merged. We have electroweak, which is
relax.
merge. Let me explain.
Relax. What you are saying is false. So what you are saying is that
I am going.
What you are saying? Can you have temperature without matter?
What do you mean by temperature without matter? Your questions are.
Can we have temperature, coldness of a body? Can we have temperature without matter?
Einstein's equations of general relativity. Energy, right? Energy can be converted into matter. So what do you mean?
Can we have temperature without matter? Yes or no?
I don't understand your question. So
can we have temperature? Can we have density without mass?
I can't respond to this question.
Okay, thank you very much. So my next question is this. I have 1 minute.
Yeah,
concerning gravity.
Yeah.
For gravity to interact with like the star formations and others, you need gravity.
You need gravity. Yeah,
okay. So what is the driving force of the gravity?
Well, in understanding the universe, you find that gravity is an emergent force. It's not even how.
So it just happens to be there.
Take your time. Take your time. The reason why we don't even have a good conceptualization of gravity is because Einstein's equations disagree with quantum mechanics. You get infinities in your figure. What that simply means is that you need a theory of quantum gravity, right? So at the quantum scale, Einstein's equations don't apply. So what is
the driving force of gravity? So you don't know. You don't have an answer.
I don't know.
That is very normal. So it's not very normal. This is
very normal.
Okay.
Is that the time?
The end. Yes.
Okay.
Thank
you very much.
Thank you very much for such a wonderful cross-examination between our two brothers. Now we are moving on to questions from our audience. And I believe they've done justice to that. But before they come in with their questions, or before I read their questions, I would like to ask these questions to both parties. And I'll begin with our brother Eric, so since our brother Marcus has begun all this while. Brother Eric, please kindly attend to this question. In 3 convincing points, tell us why the world or the universe has creation to be its origin.
Okay, so number 1, when we look at the observable features of this universe, the evidence that we have, it simply couldn't have happened by chance. Why? The law of cause and effect is a law, and he didn't even touch it. You know why he didn't touch it? Because he can't disprove it. It's a law. The law of cause and effect tells us emphatically that yes, indeed, you can't have material effects without causes. And he didn't even touch it. Can we have the Big Bang just pop into existence? He says no, because there are some fundamental particles that have been there eternally. If that is the case, then the debate has been lost by him. Then the question of origins of the universe to be the Big Bang is false, because the universe has always been there. That fundamental particles created the universe according to him, so it has always been there. The universe has always been there. And when you look at Fred Hoyle, physicist Fred Hoyle, Professor Fred Hoyle, he said that to have that concept that the universe is eternal is completely nonsense, and he has degraded to steady state theory that he was once, when I mentioned, he was trying to make a fuss about. For if you tell me that fundamental particles are eternal, then you are appealing to steady state theory. That's what they were saying there.
Second point. Oh, that's all.
The second point is the design we see in the universe. We have information. If you have information in the universe, information only comes from minds. And information theory tells us that, information science theory tells us that you can only have information coming from mind. Example, the DNA. It's so complex that it couldn't have just happened randomly. His position, which is the naturalistic way, the Big Bang model, can't explain how we have DNA. That's why he was trying to just find a nice way to go about it. So information comes from a mind. Where does information come from? The mind of God, not from the natural.
The third point, or that's all.
These are the 2 points I gave.
Brother Marcus.
Yeah.
In 3 convincing points.
Yeah.
Tell the world that
the Big Bang happened.
Yes.
You can observe the cosmic microwave background, which has been measured at the level of precision of 99.997% to be 2.7 Kelvin. That's one evidence. We have observed the expansion of the universe just as the scientists calculated to, resolutions to Einstein's field theory of general relativity. Yes, so expansion of the universe, light elements, which is the third, basically what we observe, neutral hydrogen atoms forming at the early stages of the universe. So we have about 70, more than that, 70% of the entire universe made out of hydrogen atoms, and then helium forming the rest. And then the ones that you find, the elements that you find on the periodic table, most of them from the third to the last, just constituting 1%. So these are things that have been experimented with.
Second point.
I've mentioned all the three.
I've mentioned all the three. Very much. Now let's move on to comment section, and this question I think it goes to Brother Marcus.
Yeah.
Does the Big Bang talk about the evolution or the creation of the universe?
It talks about the evolution of the universe from a particular point in time.
All right.
Can I comment on? I think you should have 1 minute comment on the answer.
On that
yes. If I give answer, we can comment on it.
You also can comment on his answer.
Okay, let's do that.
All right.
Let's do that.
So brief one.
Yes. His answer earlier contradicts this. The question was that does the Big Bang, the topic origins of the universe, Big Bang, creation of Big Bang, and he's saying that it is the Big Bang. But then he's saying that fundamental particles are eternal. They have been always there. So that means that the universe has always been there. So he has refuted himself inconsistency.
Okay, thank you very much. Another question, Brother Marcus.
Yeah.
Sorry, Brother Marcus says he wants us to show the creation story so that it can be replicated in the lab. Can the Big Bang be replicated in the lab?
Exactly. Just as I mentioned, you go to the Large Hadron Collider, just Google it at the European Organization of Nuclear Research. They have recreated conditions in the Big Bang. It is known. Just Google it. You find it.
Thank you very much. Comment.
That is completely false. Again, Google it for yourself and see. Marcus is telling lies. Okay. It's not true. Just a minute. When you look at the issue of the cosmic microwave background radiation he has been making noise with, you see, there's a problem. That is why they brought in the idea of inflation to solve the problem. Because of what we call the Nobel laureates, those who won the Nobel Prize for the Big Bang, that's CMB. It was a project called COBE, C-O-B-E. They realized that after launching another project on that, which is called WMP, they realized that is false. It's not actually uniform as it was supposed to be. That is why Alan Guth later proposed what he called the inflationary model, which he mentioned once, and the dark energy. So he doesn't have evidence for, and he doesn't know because he has not studied the physics. He doesn't know because he has not studied the physics.
Okay,
yes.
Thank you very much. Another question to Marcus Imbro.
Oh, I like it.
This physical world proves a pattern, orderliness and rules, which bracket natural laws existing. And one, where are the origin of these? Okay,
so from the infinitesimal points of infinite energy and density, these forces what you call patterns existed, and they have evolved to be what we see them today. So cosmic evolution is what the Big Bang explains, and it explains it perfectly. That's as I cited the example, the super force, which was all the fundamental forces together, energy, and everything that you find at that singularity. That is the point where, for instance, the string theory is trying to figure out loop quantum gravity. They are working on this to figure out how to explain singularities, because we have things in our universe like a black hole, a singularity of a black hole. We cannot tap information from that singularity, so we have to come up with theories to understand how it happens. And when we do that, that wouldn't be a question. Definitely, when you look at history, about 200 years ago, Einstein wasn't there. His theory of general relativity wasn't published, and Newtonian gravitation was held. When he came, he changed the whole thing. That is science. It takes time.
All right. Thank you very much. It takes time.
So that is one thing that almost everybody who doesn't have answer. Oh, we need more time, and that's why they estimated 13.8 billion. They think by giving them more time, then they think they will be able to come up with rescue devices. That is false. Your question, you are saying infinitesimal. Where did that thing come from? Okay. And you are saying that it's...
Sorry, there is a question on that. So let me ask the question on what you want to say, because sometimes question is exactly that.
Yeah.
Question for Brother Marcus. Where did the infinitesimal points that mark the beginning of the Big Bang come from?
Scientists don't know. They don't know. That is why they don't know. That is why they are looking for a theory of quantum gravity. They don't know, because a singularity, if you go into the quantum, a singularity is a point where our mass just runs out of the roof. You get infinities. It means that gravity itself cannot be renormalized at that scale because it is too weak. And to reproduce that is what I mentioned earlier. You have to build a particle accelerator like the size of the universe. We don't have the resources to do that. So you would have to depend on theory. And it's the scientific field that's going to produce that theory. Right. Definitely not from.
Did you just hear what he said? Perspective. You need to rely on what? Theory, not experiment. But he was here shouting earlier, experiment, and Big Bang is not an observable feature. We don't have it. And again, he mentioned the formation of the stars. Please, the question the person is asking is linked to this. For you to have gravity, you need the driving force of gravity, which is
graviton. Yeah.
Yet, has the graviton been observed? Has it ever been observed? No. So you see, what he has, all that he is doing today is faith. Why am I saying it's faith? It has never been observed. He is just like I am saying that it's a supernatural event and he's trying to make a fuss out of it. What he's saying, it's not observable. It's also faith. Why? Look at it. For you to get the gravity, to form the stars, you need graviton. For you to get graviton, we don't even know what graviton is. Yet you are here claiming that we know how star formation through
from ignorance.
So it's false. So it's false.
All
that
right.
concept is false.
Thank you very much. And I think this will be the last question to our brother Marcus. Marcus, you spoke about the creation experiment at CERN.
Yeah.
That creates the Big Bang conditions. That replicates. Okay. Yeah. Which instrument at the CERN lab measures the temperature at that trillions of
Perfect question.
Well, there are superconductors. There are detectors like Atlas and so many, the LHC. So just find out. This is something that I can't find all the time talking about. So.
All right. Thank you very much.
Atlas is one of them.
Okay. Thank you very much. Now,
can I comment? That is another way of saying he doesn't know. So you carry on. Yes. He doesn't just know.
You should. Yes, like you heard from him. That's all.
Yeah.
It looks like our brother Derek didn't get any question, but then I would have a question for you.
All right.
I want you to. This question, Marcus must also answer.
Oh, go ahead.
So I want you to prove to the world again, in just a point, that the Big Bang theory can't hold.
Okay.
So you also do the same. That the creation can't hold.
Okay. So to falsify the Big Bang, and why I'm saying that the Big Bang never happened is this. When you look at what we observe today, it doesn't agree with what the Big Bang says. There are certain things the Big Bang proposes, and one of them is this. For the Big Bang to be true, it relies on what we call the cosmological principle. For the Big Bang to be true, it has to rely on cosmological principle, which says the idea that the universe is uniform and homogeneous. Marcus wants to run away from this, and he keeps on going to the CMB. But he doesn't even know the research behind the CMB, that after they won that Nobel Prize, later, that was why Alan Good proposed what we call the inflationary model. It is because it is false. Why? When you look at that cosmological principle, it says, if the Big Bang is true, it should be homogeneous. But I just read, and he doesn't know. He says he is trying to discredit the Professor Stephen Hawking, who said that in which it was concluded that the difficulties in the original scenario were insurmountable. It didn't happen. It's not homogeneous. We see clusters of galaxies. We see inhomogeneous universe. Yet, if the Big Bang is true, we are supposed to see homogeneous atmosphere or homogeneous universe. We don't have it. Big Bang it didn't happen. It's just like scientists they don't want to admit that the supernatural created what we have. So some scientists are saying, okay, then it's a Big Bang. Later they'll tell us steady state. Later they'll tell us plasma model. Just trying to run away from the main point. So the Big Bang doesn't agree with evidence. If it agrees with evidence, he is supposed to show us. He's supposed to tell us, how did we have the immaterial in the universe? And he's now telling me what is the immaterial. Marcus, as smart as he is, doesn't know what an immaterial element is. It's because he has assumed the wrong position. That is why.
Thank you very much. To our brother Marcus.
The originality is a myth. That's it.
That's
a myth. Yeah, it's a myth.
Okay, thank you very much. And I think someone has just sent a question to our brother Derek.
Yeah.
Was the universe, including the things like plants and animals, created, matured already?
Is that a question?
Yes.
Okay, thank you very much for asking the question. Yes, they were created matured, and that is with the radiometric dating that he was talking about. Today, when we look at the universe, why is the age of the universe very young? Why do we have that? It is because when God created the first things, they were created old. You see, for his theory to hold, the assumption is that you should know the starting point of the light. You should have, and it's also supposed to be constant. These are assumptions, but we don't observe that. If you go to a room where you have a burning candle, if you want to know how long the candle has been burning, you need to know the starting point. Else you can only assume, and assumptions will be wrong. And that's what Marcus has been relying on, the way dating. And it's wrong. But when we come to the Bible, yes, they were created old. The first man. And some of the evidences actually for creation is this. And I said I was going to mention it, and I'm ready to mention it. It's the 6,000 years Mercury. Yes, the Mercury's magnetic field is young. And actually, NASA has a probe that has estimated that the age of that Mercury is now 6,000 years. In agreement, and the research is here. And you see, Marcus will giggle, he will laugh, but I have a last point at the end of my presentation. Can you show it, please? And I intentionally left that one out. Please, can you show my last slide? The last slide, it has the point. Please, Jonathan, can you show it to us? Yes. These are the predictions of the creation model. I intentionally left it to this point. It has confirmed this prediction. Strength of planet's magnetic field. When you look at it, the Big Bang is true. The estimate we are getting from it is false. Observed features, strength of the planet's magnetic field, decay of helium release, radio halos in metamorphosis. Okay. A lot of pointing there. I don't want to rattle all of them like that.
We have to proceed and move on to our next stage of this debate. Finally, we've come to the end of the debate, and I would like to thank you all for your patience and your attention. But before we end, I would request that the two parties give us a concluding statement from our brother Marcus.
Thank you very much, Seth. That was quite entertaining. That is why I was laughing all the way. So what I would advise everyone joining us today is there is a ton of knowledge out there. Go out there, research it, because our civilization is bound for doom if we do not research, if we do not ask questions, fundamental questions, and find answers. Most of our technologies today are because of materials that I presented. And it is because people are actually sitting down and asking the questions they should ask and designing experiments to find out things about the universe, to understand the universe. Because the more you understand the universe, the more you can use what is in the universe to your advantage. That is what I will find here in our part of the world. You go out there, most of the experiments that I mentioned, they are carried out in some land. So, obviously you won't find the creation research to look into this matter, but that's just a matter for another day. But we should advance human civilization by encouraging research, curiosity, asking fundamental questions. And when we do that, I am highly hopeful and I'm optimistic that in about the next 100,000 years, you will be able to conquer a lot of forces in the universe, use them to our advantage, and the human species will not go extinct like so many species on Earth have gone. And we can survive it, even to the death of our star, which is in about 6 billion years. So if that is done, we can escape that and probably colonize another planet on another system. It is all about theoretical, experimental, and observational science. Thank you very much.
Thank you very much, our brother Marcus. Quickly we move to our brother Derek Danso for his concluding statements.
Okay. Thank you very much. Ladies and gentlemen, I would like to really appreciate your time that you have spent with us. Yes, crossfires are like that, so yes. But something has happened right now. I actually predicted that before we end the conversation, Marcus would give up the topic. How did I know that? Because his position is not true. The Big Bang never happened. So you have to find a very nice way to skip the topic. And that's exactly what he did. How did he do that? The topic says, origins of the universe. Origins of the universe. That is to say, the beginning, the starting point. Then what is the topic? He gave up the topic by telling us that when I pushed him with the evidence, he says, now matter can be eternal. Now he went to what? Virtual particles. And he said, Google it, read it. It's a clear sign that he has no answers for you. Please, and I would also encourage you, please do the research yourself and see. whether what he's saying is true. For virtual particles to pop into existence, you need what we call quantum fluctuations. For quantum fluctuations to happen, you need energy. Yet the Big Bang is telling us that it is the origin of the universe, including energy. Self-contradiction is a sign of a failed argument. Marcus failed. And if you're out there holding to that position, I indulge you. And I am passionate about this because once you neglect the idea that a creator made all these things, then you don't have a basis for so many things. For what? Where's your basis for morality? And I asked him, how do you know the immaterial? Then all of a sudden, the all-brilliant Marcus has forgotten the definition of immaterial. When I asked him about matter, the all-brilliant Marcus all of a sudden has forgotten the meaning of matter. When I asked him about spontaneous generation, all of a sudden he doesn't know them. Why? Is it because he's not smart? No. Marcus is my good friend. He is smart. He has a good degree. Yes, he's smart. But the position he is holding is false. So he has to find every way to explain it. Did you realize that? And I had, normally in every debate, I pick up a space where I will document the attacks the person gives to my position. Marcus, how many did you give me? 0. He didn't deal with my point. I brought law of cause and effect. What did he say? Go and Google it. What did he refer to? Constantly referring to cosmic microwave background radiation. And he actually showed us today that he doesn't really understand the science. And I'm not insulting his intelligence. Marcus, please, this is the research. I'm giving it to him. Please give it to him. You can go ahead and read it, and it will show you because you did not know it. Then let me quickly run through my point. What I mentioned was that how do we know that this universe was created? Information. The DNA is information. The DNA within you, within me, is information. Information science theory tells us that minds give us information. Information that doesn't happen. If I take alphabets and I throw them into the air, they are not going to form nice words written. No. A mind has to arrange them. That is how the universe works. So for him to assume that position is false. Now, some of the big problems with the Big Bang, maybe Marcus is not aware, but you, since he said you can go and Google it, I'm going to run through them. 1, the horizon or the flatness problem. It's a big problem for the Big Bang. Number 2, a lack of evidence for the inflationary model. Well, where did inflation come from? Is it an observable fact? No. Yet it is what is explaining Big Bang. Number 2, lack of evidence for dark energy and dark matter. There's no evidence for it, has never been observed, but here is Marcus trying to tell us that it is an explanation that science is still trying to explain. No, we have not even observed it. It's not science, it's faith, so he should admit it. Now, the smoothness problem is a big problem for Big Bang, the cosmological principle that is homogeneous. He kept on going back to the CMB, the cosmic microwave background radiation, which he did not know that it's not homogeneous. It was estimated to be homogeneous, but that picture he showed is not homogeneous. Again, missing antimatter. We are supposed to see if Big Bang is true, the same number of matter and antimatter. What do we have? We don't have equal number of matter and antimatter. We have more matter than antimatter. Number 2, the Fermi paradox. Number 3, the anthropic principle. Number 10, the origin of life. Big Bang can't explain the origin of life. Number 3, Darwinian evolution lacks solid evidence. Number 12, origin of genetic information. How did genetic information come about? That's what I mentioned, the information theory. Number 13, evidence of common ancestry is lacking. And all these plenty things, and the last one, number 15, evidence for an old earth is lacking. This is my last point. When we look at the universe, the number of people we have on earth, if the Big Bang is true, according to the Big Bang, the earth evolved around 4.5 billion years ago. Man got to the earth around 3 million or 4 million years. We've not been here for that long, estimated according to them. If that is the case, even it's in millions. The population of earth right now is about 7.8 billion. If the Big Bang is true and the evolutionary model is true, we are not supposed to be 7 billion. We have been on earth relatively young. And when you look at those who do statistics concerning the population of the earth, you would realize that it doesn't fit the Big Bang model, but rather about 6,000 years this world has been. Thank you very much.
Thank you very much, our brother Danso and our brother Marcus Imbro. Today has been a great day. We thank you all our viewers and all our audience. Those of us who have been with us, I think there are more than 30 people with us still online. Thank you for your consistency and being here, sharing and asking questions here and there. We are so much grateful for all of you for being with us, and the managers of the studios of Chariot TV for permitting this program to take place in their studios. We plead with you that you keep sharing this program and also be more convinced that we will be bringing you more important and exciting programs from Spotlights on the Word as well as Chariot TV. We thank you so much for being with us till this moment. We are grateful so much to our brother Tegdanso and our brother
Marcus. Interesting conversation.
Yes.
Thank you very much, bro. Thank you.
Managers and producers behind the scenes who are doing so well to bring to us whatever we see outside there. You will have all these programs on our social media handles and including our YouTube channels as well. Kindly like and subscribe to all these pages, and then you'll receive more exciting programs from us. Thank you very much, and so then we shall meet again. Bye-bye.